Hi, I'm Eric Bogatin with BeTheSignal.com, reporting for Real Time with IPC. And joining me today are Rich Meltz from Intel and Don DeGroot from CCNI. Rich, let's start out talking a little bit. You guys are both involved in new test methods for materials and interconnects for high-speed, high-frequency performance. And Rich, one of the things that is your top of the list interest right now is loss in interconnects. What's the deal with loss in interconnects? Why is that important?
Well, Intel is here because it's the end game. These are all the pieces that go into building computers. The IPC builds all the pieces that we need. There was a time that most of what was going on the board was interesting, caused a little bit of distortion and reflections, but at the present time, products on the horizon have 90% of the signal lost on the boards. So why is loss important? Well, 90% is lost on the board. That is a very strong
And when you say loss in the board, that's from the dielectric materials, from the copper, the design features?
Absolutely, absolutely. Now, we can, our silicon compensates for some of that, but it's possible with the wrong selection of materials or arbitrary selection of materials in an environment to penalize or steal 75% of the silicon performance. So we think it's very important. We like to get our chips to have the most amount of performance. When I talk to silicon folks, they say, why can't you just fix the boards like we fix our silicon every 18 months?
Yeah.
Well, I'm trying.
Yeah, and of course, when you try to fix the board and fix the materials, that means lower dissipation factor materials?
Yes, it means lower dissipation factor, better management of vertical structures. It means better copper, smoother copper. It all rolls up into being loss, and it's important. And right now, specifying each of the individual pieces for each of the materials is very important to get to know how each of the pieces of material behaves. But when you put them all together, they also have their behavior. And that behavior is important because that's the aggregate end effect that goes into computers.
So it's more than just kind of sub-optimizing the components that go into it. It's also, the phrase I've been using is an ecology, where all the pieces play together and you make one change with one, and that may have unintended consequences with another one.
Absolutely. And basically, if you look at this, when we look at our computer systems, we're looking to fulfill Shannon's capacity there.
Get the highest bandwidth out of your interconnect.
You can have the lowest signal to noise. And to do that, we need more signal, because the noise just seems to getting worse and worse and worse. And our circuits too, our electrical circuits, right now do compensate for noise, for loss, but
how much loss can you tolerate? I mean, you can't have zero loss. Nobody can afford that. But what's the kind of level that's acceptable?
Let me give you a gut feel for let's take an IEEE standard, 10 gigabit standard. It's normally considered, if you have a channel somewhere between 20 and 25 dB at Nyquist, you can achieve successful communications. Now, real channels in high-performance computers are considerably less than that. But that's sort of like the limit of where 10 gigabit IEEE is right now.
So you'd like to have like minus 20 dB as kind of the insertion loss, differential insertion loss as acceptable. So minus 20 dB is like 10% of the amplitude left.
There you go. I said 10% of it there.
That's right.
10%.
So that's the kind of number you want. And from a board level perspective, technology-wise on the board, if you could point to like the top two or three features that you'd like to see improved in the board, what would that, keeping in mind that they interact, but from component supplier, what would you like to see?
I would like to see low loss dielectrics at a very economical price point that's worldwide available. I'd like to see surface roughness treated in a low-cost manner. And I'd like to see treatment of vertical structures solved.
And that means the vias primarily?
Vias, connectors, anything that takes you from one trace to another trace.
Okay. And do you see the big issue there as the via stubs that are involved, or is there some other issue in the design of the vertical structures?
It's not a transmission line. So when you have transmission lines, it's very well defined how they behave, what the losses are. When you go from a vertical structure, you're a non-TEM wave, you have that crosstalk.
Right, and coupling into the other modes.
And yes, it is stubs and it's reflections. And
right.
It becomes much more complicated.
So
but we're focusing here on the board transmission line loss. That's what the standard's focused on.
Okay. So we see that there are a lot of issues, especially in the current generation products for the high speed and the combination materials design issues. And Don, you're chairman of the D24 task group. That's primarily focusing on the high frequency, high speed effects. What do you guys cover in your task group?
Right. So IPC has had for some time subcommittees that develop test methods for the high speed and high frequency electrical performance. One of the beauties, I think, of our D24 subcommittee is that we work from the material specifications all the way up to interconnect specifications. They end up with people from OEMs like Rich. They end up with people from material manufacturers and PCB fab and test and measurement companies. And the idea is that we're really kind of solving the test methods that we need to have in place in order to specify performance, all the way from the dielectric material all the way up to an interconnect type of a test structure. And I think that kind of holistic view that the committee brings is quite important.
So you have task groups that are involved in just the materials characterization as well as structures that you build with the circuit board elements?
That's correct. We have one task group that focuses predominantly on high frequency materials, so it's dielectric properties. We've had in the past 2 task groups that work on interconnect measurements, one on delay and one on loss. And we're quite happy to be announcing at this meeting that the delay and the loss test methods will be seeking approval in a committee today. Hopefully in a little while we'll know the answer. Yeah.
And I know you guys have been spending a lot of time the last year or so working on test methods for loss,
yes.
And you've got a document ready for approval on that.
Exactly. So the test method that Rich's task group worked on is kind of a nice test method on loss because there are competing instrumentation, there's competing fixtures and parameters that people go after. And I think the task group showed that there is a correlation between those methods. And the test method is very encompassing in the fact that if Intel chooses to spec something in that test method, suppliers would be able to use that document to measure it in very much the same way, or use a test house to be able to do that for them.
And Rich, you're chair of the task group that's involved in specifying the loss test methods, because that's so dear to your heart. Yeah.
Correct.
And Don just mentioned there are 4 different methods that you guys are proposing. They're looking at not just the material loss, but like you were saying earlier, the holistic loss of interconnects.
Exactly. The loss of the transmission lines and traces as they're mounted and manufactured on printed boards.
And are these tests that could be applied by the laminate suppliers or the fab vendors or the final assemblers? At what stage are these tests going to be applied?
It's interesting. The methods do span across pretty much the industry. They're applicable for printed wiring board shop floor control. They're applicable for vector network analyzer measurements in a laboratory, and that would be looking at just some very detailed and parameters of loss.
And these test technologies, because loss is such a complex issue and involves real high speed kind of things, it's not the kind of general tests that a lot of fab vendors are necessarily going to be familiar with. And so there are a number of, you're proposing that external test labs be able to implement these kinds of tests.
That's a potential. It also, one of the methods can be employed by 80% of the equipment that's in printed wiring fabs right now.
Wow. So some of these tests are suitable for fab vendors,
right,
as well as external certified labs.
That is correct.